Calvin cycle utilizes the ATP so when you go through the light reactions, you make NADPH, you make several molecules of it, you make ATP, and by the way, this happens really fast. It's just making a bunch of these, making a bunch of these. And we're going to use the NADPH and the ATP to make glucose. Remember, the goal is making glucose. We already saw where water came in and where light came in, and we saw where oxygen came out. That was all in the light reactions. Now we got to see where CO2 comes in and glucose comes out. That's the goal of the Calvin cycle. Are y'all with me? Half of you aren't even looking up here. You got no idea what's going on. So, this is the thylakoid membrane. This is the stroma. And these molecules here will represent carbon dioxide. How did the carbon dioxide get in the stroma in the first place? Well, remember the stomates in the leaves? They're little holes, they open up, and the CO2 gets in the leaf.
Can we see stomates?
You can see stomates. We'll look at them under the microscope.
I said stomates.
Oh, stomy?
Yeah.
You mean the hand puppet stomy?
Yeah.
Oh, I'm back! Yay! What's been going on this year? Nothing? Oh. Hey, we can put a little mask on him.
Oh.
This is terrible. Okay. So anyway, yeah, the stomates open up, and the CO2 goes right into the leaf, and the CO2 can diffuse right through the membranes because it's nonpolar. It can go right through membranes. So it can go right into the chloroplast, and it's just floating around here in the stroma. It could go through this membrane too, and there'd be some floating around in here, but it doesn't do anything in there. These are molecules right here called RUBP, ribulose biphosphate, also known as RUBP. You don't have to know the names of these molecules, but they would give them to you on the test, unless it's a bonus or something like that, I guess. But where is, hello, there we go. See the RUBP right there?
Yeah.
That's what we start with. It's a, why did I have it looking like this? Because it's a 5-carbon molecule. It's got 5 carbons. It's also got oxygens connected to it. It's got hydrogens connected to it. It's got phosphates connected to it. Can you guess how many phosphates are connected to it? It's called ribulose biphosphate.
2.
Yeah, it's got 2 phosphates connected to it. But if I tried to stick all those molecules on here, it would be too crazy. So I'm just going to show you the carbons. Okay? Are you with me, Dylan?
I'm with you.
Seem like you're on the computer looking at something. Now, so the first thing that happens in the process, just follow this along. The RUBP attaches to the CO2. The CO2 comes in and attaches to the RUBP. You want to see that? We're going to do it 3 molecules at a time. Click. Here is a more detailed version of the Calvin cycle.
What's up with the projection?
I don't know. I'm not liking it. Go.
Yeah,
Going dim, then bright. Ooh, it stopped. Oh. So, do you see how it says 3 molecules of CO2 attached to attached to RUBP. Here's RUBP. This is what the molecule actually looks like. Do you see how it has 5 carbons? 1, 2, 3, 4, 5. We're ignoring all this other stuff, but you're just looking at the 5 carbons. There's an enzyme called rubisco that hooks the CO2 up to the RUBP. And this enzyme, pretend it's my hand here, will grab the CO2 and hook it to the RUBP. And now we have a 6-carbon molecule. We have 3 6-carbon molecules. Now, these 3 6-carbon molecules are very unstable. And as soon as they catch the carbon, Greta, are you with me?
Yeah, I'm with you.
As soon as they catch the carbon, these 6-carbon molecules break into 3-carbon molecules. And that's why they show this stage 1. They show this stage 1. You see these 3-carbon molecules. There's 6 molecules of, we call this molecule PGA. 3-PGA is what it's called. They're 3-carbon molecules. They're not called RUBP anymore. What are they called? PGA. So, we call this whole process carbon fixation because the carbon molecules have attached to the CO2 molecules have attached to other molecules. So we say when anything attaches, we say it's fixed. It's fixed in place. So the 3 CO2 molecules are fixed and attached to the RUBPs, which again break up into PGAs. Now what happens next? You see ATPs come in and change to ADPs. What they do is they drop off a phosphate. So each of these ATPs will come in here and drop off a phosphate and attach it. And there'll be 6 of them in total. Now each of these will have 2 phosphates instead of 1. But anyway, that's called a reduction of PGA. A reduction means it's going to take in electrons. And where do the electrons come from? NADPH. Each NADPH comes in and drops off a hydrogen and drops off electrons. And each one of these is going to do that. And that's what the reduction part is. If you pick up electrons, you have been reduced. Your charge has been reduced. It's more negative. And that happens to all 6 of them, not just 3 of them. Are y'all following me?
Does it always happen with 3 different molecules, or does it happen with like 1 at a time?
It's actually it's easiest to think about it in terms of 3 at a time, but there's actually thousands of them there. It's happening to thousands at a time. But it's easiest to consider in multiples of 3. I'll show you why in just a second. Now we have this new molecule. It's called GA3P. And that's one that you should probably know the name of, GA3P. That's what these are called now. Now that they picked up the electrons, they picked up hydrogens, they got some energy from ATP when the ATP broke apart, and now we take one of these molecules and we store it away. And that's what you see here on this arrow that goes down. You see one of the molecules getting stored away. One molecule, GA3P. What happens to the other 5 molecules of GA3P? These other 5 molecules of GA3P, with the help of ATP, more ATP comes over here and releases energy. But these molecules are going to be converted back into the RUBP we started with.
So we made
to make one of these.
That's easy.
That's how it works.
Not very efficient.
Yeah.
It actually is. It's more efficient than the most efficient motor we've ever created.
Hmm.
It's about 40% efficient in nature. But it could reach efficiencies much higher than that. Your car engine's about 10% efficient. Interesting, huh? You want to see it again?
Yes.
Let me get these started back here. I need another process. Still one over here. So we got the ATPs. We got NADPHs. We've just made them in the light reactions. I'm going to do the whole thing again for you. You ready? It's exciting, isn't it? Red, are you watching?
I'm on.
Here we go. What are these things? CO2. They represent CO2. CO2 comes in. It becomes fixed or attached to our UBP. That immediately breaks down. Now we got these molecules called PGAs. ATP comes in and gives them phosphates. NADPH comes in and gives them hydrogen and electrons. No. They're just